Good afternoon to everybody in Asia. Good morning for the European players. We are quite happy to have you on this session today, which is the second one of three slots that are happening in these coming days. One happened last week, another one to happen early May. This subject of industrial demand side flexibility is key for us, but is also key for the energy transition or the sustainable development that we all hear and work around in the world. I'm quite pleased to launch and to introduce this session because we would talk about or would get the feedback of some of our key players in the region about this topic of industrial demand side flexibility, but also sustainable development. I will welcome Baptiste Guillot-Rollin, who's project director for Energypool and taking part actively in the deployment of Energypool in Asia Pacific for the benefits of our clients and partners, mainly utilities, but also big heavy industry players. And you will notice that this would be not only heavy industry players, but mainly all industry players that can play a role. We will have also later on Dr. Hasnan, who's the Chief Strategy Officer at TNB Research, with whom we have the chance to work very closely on these topics for the Malaysia Peninsula approach. And also Takeshi Ishimura, who's the CEO of Energypool in Japan and wearing this flag of energy transition, industrial support to grid purpose, thanks to the relationship we have established with Tepco, thanks to him for the last few years. I wish you a happy seminar and we will for sure welcome all your questions at the end. Thank you.
Thank you, Emmanuel. Yes, Baptiste, are you ready to?
Yes.
Start. Thank you.
So hello everyone. Thank you for joining this webinar today about demand side flexibility. I'm Baptiste Guillot-Rollin, and I've been working with Energypool for more than 10 years on flexibility topics. And I will start this webinar with a short introduction of our company. So Energypool is a smart energy manager, we'll say a world leader in demand response and energy flexibility. The company was created in 2009, and actually we were the first demand response aggregator in France. Now Energypool, it's a team about 100 people worldwide with several regional operation centers. There's one in France, there's one in Turkey. There's also one in Japan that operates on behalf of the Tokyo Electric Power Company, also called Tepco. So worldwide, we manage several gigawatts of flexible loads, batteries, distributed generation. And this is a total of about 1,000 CNI customers that are connected to our VPP platform and that we optimize every day to deliver balancing services to the grid system operators, but also to the utilities. So this webinar will focus on Southeast Asia because the region is going through many changes and challenges, and we think DR is going to play a key role in the area. Just to start with some key facts, in fact, the region is evolving at full speed. The economy is expected to increase by 5% per year, and the ASEAN economy should become the fourth largest economy in the world by 2030. So obviously, this situation has a significant impact in the power demand. And some key figures here are that the demand increased by 6% per year until now and should double by 2040. In the meantime, what we can see on the power grids is that they are not fully interconnected yet, and energy markets are not fully in place either. And the last point to mention, and not the least, is about renewable energy, because to contain CO2 emission, the ASEAN country members are pushing for renewable energy. And here we are talking about reaching 35% of share in the installed capacity in the mix by 2025. To So to sum up these facts, I would say that there are many additional power capacities that are required in the coming years, and the power grids, but also the utilities, will undergo many challenges, investment also, and modernization. So speaking about challenges, here is a slide to understand why demand response is so important. So on the left, you can see that over the years, there are more decentralized plants integrated in the grid. There's also non-dispatchable and intermittent plants, such as renewable energy, that are taking a larger share. And finally, the demand is more flexible and less predictable. So in short, there are fewer dispatchable assets in the grid, more distributed generation that is difficult to predict. And this is combined with a growing and less predictable demand. So ultimately, this leads to new challenges for the grid. I can mention grid instability, congestion, but also volatile energy market. And one of the solutions to mitigate the situation is to push forward the smart grids topic, but also to create new market for demand response. And the main gain for that is more flexibility in the grid to be able to face the challenge. So in this context, recently, the Center for Energy in the ASEAN released the phase 2 of the Plan of Action and Energy Cooperation. They came up with several strategies to support the economic growth, but also the energy transition. Here in this slide, we highlighted just some of them because they are related to demand response. So the first strategy to mention is power grids. So significant investment will be made here to support the demand, but also to enable a larger share of renewable energy. And related to that, they mentioned that considering other flexible resources is essential, and such as demand side management, so demand response. A second strategy to mention is about energy efficiency, which is key in the area because 40% of the peak demand should come from the cooling in 2040. So equipment should be more efficient. But there's also a large topic on industry energy management. About that, the Center for Energy recommend to promote energy management in industry. And this is to reduce the demand, of course, but also to increase their competitiveness. So with these two examples, we can see that demand side flexibility is a topic in the area, and we will deep further in demand response from now. So what is demand response? So basically, in a power grid, the challenge is to balance the supply and the demand. Before, generation assets were the only resource available to balance the system. But with technologies and new regulation, we can see now that demand response contribute to system balancing in many countries. And DR can bring several kind of services reliable to the grid. I can mention the peak shaving for the capacity needs, but also the tertiary reserve for the power grid safety. There's also the frequency regulation for the grid frequency response, and it can even participate to the wholesale market. So what is demand response? So practically speaking, demand response is provided by consumers. They adjust the electricity upon a request from the grid system operator or the utility. And for that, they receive a direct payment. We have different kind of operation. There are temporary operation or continuous operation. Here we have three use cases. So the first one in the left, curtailment, is in fact a consumer that can decrease the consumption for a few hours, for example, during a peak demand. And the result is exactly the same as the power plants that produce more. The second use case in the middle, stimulation, it's a consumer that can increase the power consumption. For example, when the wind generation is too high, and the result is like a power plant that produces less. And finally, the third example on the right side, continuous operation. This is a consumer that can participate in the frequency response. In that case, the consumer adapts the power consumption every second, up or down, according to the grid frequency or even the AGC signal. So consumers can participate in many kind of products, and demand side flexibility is everywhere. I could mention electro-intensive industry. And by the way, they are very interested in demand response. Energy is key for them. And we can even see now that when they plan a new plan in a new location, demand response services tends to be decisive for settling the plant. So how to manage demand response operation? So obviously managing demand response is very different from conventional power plants. Consumers are not power plants. It's made of many different sites, many different technology and processes. For instance, Energypool has more than 1,000 sites connected to our VPP platform. And for each one of them, before going to operation, we have to analyze, enable our customers to participate. And through the aggregation, the overall portfolio can act as a virtual power plant and deliver reliable and flexible services, which is not possible with one single site. But of course, this requires to understand each of the process, each of the consumers, and to have dedicated tools such as software, hardware, and of course, optimization. So in this slide, you have a concrete example of what aggregation is. This was in France with RTE, which is the system operator in France. So RTE was facing a significant peak demand due to the weather, but also a lack of reserve margin. And on that day, we dispatch more than 100 customers and deliver up to 438 megawatts. Over the entire day, this is about 1.7 gigawatt hour. So this is a concrete example, and this will have not been possible without software optimization, also automation, and of course, aggregation. This next slide is more to explore the full possibility of demand-side flexibility. This is a frequency response. So back in 2014, Energypool was the first player in France to provide frequency response with a consumer. So in practice, it means that the consumer adjusts the consumption every second according to the grid frequency. So clearly, this means that when the frequency is below 50 Hertz, the site reduces the consumption. And when the frequency is above 50 Hertz, then the site increases the consumption. So with these two use cases, we wanted to show that demand response can provide many services, so from peak shaving, but also frequency response. But it also brings benefits to all energy stockholders, and this is the purpose of the next slide. So here we listed some of the benefits that demand response can bring to all stakeholders. Just for example, the consumer can generate new revenues thanks to the flexibility, which is a major asset to increase their competitiveness. For the grid operator, he will get more flexible reserve margin. And also, this is a very good asset to support renewable energy integration. On the generation side, this allows to optimize the generation costs. And finally, for the supplier side, this allows to offer new services to ensure customer satisfaction, but also to attract new international prospects. So to sum it up, implementing demand response requires quite a low investment because, in fact, the flexibilities are already connected in the grid. And it also brings significant value to all actors, to all players. So in the next couple of slides, we'll see how to implement it in a new market. So this slide is the usual roadmap to implement demand response, and many countries have followed the same step. I could mention Japan or France, and most of them have successfully implemented demand response, and they even now have a large participation. So basically, the first step is a demand response study, where the aim is to assess the potential and the benefits for demand response, and to draw the guidelines for a first pilot operation. So the second step is the pilot operation itself, which is about implementing and testing the demand response operation for the first time. And then the learning from these two steps will be the strong base for the third step, which is actually implementing a sustainable demand response market over the long term. So in Energypool, we have a great experience in that field, and we can support you for each of these steps, from the study to the pilot to the long-term operation. We supported many utilities, system operators, and authorities along this process. And we will start by digging deeper in the study. So this slide is about the demand response study, the first step, and this is the major step when starting demand response initiative. In fact, it's important to assess the needs of demand response and to design demand response programs that are relevant for you, but also for the consumers. So here's how we proceed with Energypool. So the first step is to assess the need for demand response. For instance, is there a capacity need in the future? Is there a need for spinning reserve? So through this analysis, we analyze the system in detail and determine whether or not DR services are to be considered. Then the second step is DR resources. Here it's about checking if you have consumers in your portfolio that could provide services, for instance, frequency service or peak shaving program, and to assess their flexibility potential. Then the third step is finally to assess if there's a value created by demand response. For example, do you make savings by putting demand response in the spinning reserve or peak shaving? So basically, it's to assess the value. So with all this information, the last step is then to design the DR programs relevant for you and your consumers, and to identify the barriers, which can be technical or from a regulation point of view, and to draw the implementation roadmap. So basically, at the end, you get the complete guideline and all information to set up the operations. After the study, it's now time to set up the operation. It can be in the frame of a pilot, but also in the long-term operation. So here, Energypool can offer different services that can be consulting, that can be software and hardware. But we also offer to manage the operation on your behalf. So it's a complete service that includes the software, the hardware, the commercial support, the operation management, and it works in 3 steps. So the first step is actually the implementation phase, where we will set up the operation center, the IT infrastructure, the software, and we'll start to bring some support to your commercial strategy to address the consumers. Then the next step is the customer-consumer engagement phase, which is very important to enroll them in the DR program. So in this field, we have an extensive expertise. So we will support to engage your consumers, but we also run audits on site, support them, enable them, and maximize their flexibility through the aggregation and connect them to the VPP platform. Finally, the last step is the operation phase, where we test demand response operation, or it could be in the long run. And so here we manage and monitor your 24/7 operation. And our expertise plus our software will provide you reliable operation and to propose many new services over the long run to your customers. I've reached the end of my presentation. So as you can see, Energypool can provide many services to support your demand response initiative. Demand response is going to be a very key solution for a sustainable power system in the Asian countries. And for that, we will be happy to support you. So thank you again for your attention. And I will now leave the floor to Laura for the next part of the presentation.
Yes, thank you, Baptiste, for this global overview of demand response. I guess we now have a better understanding of the value creation and of the implementation steps. We'll now continue with a specific focus on the implementation and demand response in the Malaysian power system with a presentation from Dr. Aznan, Chief Strategy Officer at TNB. So please, Dr. Aznan, may I ask you to start your presentation?
Hello. Does everyone hear me?
Yes, it's fine. Thank you.
Yes. Okay. Thank you. Thank you, Energypool, for this opportunity to present what has been implemented in Malaysia. My name is Aznan Ezrai Arifin. I'm the strategy head at TMB Research. And this project was done, I think, beginning 2018 and towards the end of 2019. We look at the feasibility of implementing demand response in Malaysia. Okay, next slide, if you may. Okay, the objectives of the study was we came up with a few things that we look at Malaysian market, Malaysian electricity system. What are the needs for demand response? We identify the objectives, and this mainly came from our grid system operator. The number one objective is providing an alternative approach to conventional sources for frequency and demand control to manage increasing fuel costs. So we cannot be doing the old ways of planting generation. We thought we need to find alternatives, and demand response is a good alternative. So that covers the first objective. The second objective is providing a perfect balancing act for the higher solar penetration expected beyond 2021. Malaysia has large solar tenders that has been issued. So now we have nearly 700 megawatts of solar. Another 1,000 will be coming in the next few years. So we need that flexibility in the grid system. Demand response, we think, will provide that opportunity. The need to strengthen system inertia by exploring customer demand response with more 1,000 megawatt generators and 730 megawatt single shaft high efficiency gas entering the grid. So we have new 1,000 megawatt generators, coal power plant, unfortunately still coal, and 730 megawatts of gas combined cycle coming to the system. We need to look at spinning reserve because the higher the size of the generator, you need to keep a higher than that one generator megawatt. So we think demand response can be providing that opportunity. And the fourth one is the possibility of decommissioning the high voltage direct current interconnection with Thailand. At the moment, we have the HVDC connection with Thailand. So we did look at the possibility of decommissioning the interconnection, but now I think it has been decided that that shall continue, but still at the maximum rating of 300 megawatts. So these are the objectives that we started off, the objectives of looking at demand response. Next. So we started off by, Energypool helped us a lot by identifying different customer segments that can provide demand response. We categorize our customers according to industry, commercial buildings, and residential. And we identify their capability, potential in providing demand response. For example, the industry, the individual curtailment capacities are large. Speed of implementation could be fast. Megawatt acquisition costs are low. Annual availability are probably up to 8,000 hours per year. Customer priority, production schedule and orders, and curtailable process complexity are high. So these are for the characteristics of an industrial customer, and the middle column is for commercial customers. Similarly, it goes with small, medium, 1,000 to 8,000 hours per year, and a low curtailable process complexity. And finally, we also look at residential, which its individual curtailment capacities are probably very small. Speed of implementation is slow to medium. Megawatt acquisition cost could be high, and annual availability are small. And customer priority is mainly comfort and health, and curtailable process complexity is low. So we map out this customer, and we actually look at all of our. We started off with industrial customers. Next. So these are a list of customers profiles selected for the DR study. Obviously, we cannot. We have names there. These are mainly large customers of 100 megawatts and above maximum demand. So we look at the profile of these customers. 1 year, I think 1 year load profile that we study. And if you look at tariff, so in Malaysia, we have something called E3 tariff. These are large consumer with maximum demand charge and peak and off-peak tariff. And then there's something called E3S. These are special tariff. And you can see that the business code description, 1, 2, 3, 4, okay, the 7 column or 8 column is primary iron, steel, electrical industry, machinery, apparatus, primary iron and steel industry, cement industry. These are all industries are now currently in Malaysia, and we studied their load profile to determine the DR resources available in the Malaysian system. Next. So there's some, I don't intend to go deeply into this. Emmanuel and Baptiste are better at this. So what basically we did is we do a smart aggregation and do a portfolio study. We combine all of them, the load profiles, and see the statistical benefits. Flex assets with low availability at a certain point of time are compensated with flex assets with higher availability at the same time. So this is a combination of portfolio that we do between these assets to come up with the DR resources available from these customers. So these are all studied with Energypool, and we come up with the amount of potential demand response in Malaysia for the customers that we studied. Next. Okay, and then we internally did an example for Langkawi Island also. This shows a profile of Langkawi Island. It shows us that there are some peaking hours for an island, and Langkawi is an island of Malaysia. It's a nice tourist island. We should all go there. So they have a maximum demand of probably about 100 or 110 megawatts. So we see that this is a good potential, a good pilot actually, if you wanted to do a demand response, because these customers are available. It can be curtailed. So we study and we think that there will be a value of, for each individual customers, about 2,000 ringgit. The value creation by doing demand response is probably about 2,000 ringgit per customer. So we did that internally, and we thought that if we ever attempted a pilot, maybe we'll go to Langkawi Island and do this there. Okay, next. Okay, Baptiste mentioned this. Okay, the DR resources can be provided by many consumers. They are electro-intensive industry, steel, cement, aluminium, industrial gas, chemical, metallurgical, chemical electrolysis, pulp and paper. Okay, these are electro-intensive industries. Some of them, most of them I see, are available in Malaysia. And there are also possibilities from on-site generation, backup generators, food industry, cold storage, combined heat and power, hospitals. Even it surprised me even that hospitals can do this, but it is a potential, but obviously not the highest priority one. Data centers, air conditioning. So all of these customers that we are available in Malaysia and can be studied. But obviously, we prioritize. We look at electro-intensive industry as our those that we chose for the study are those coming from electro-intensive industry. I need to mention that electrolysis is something of interest now in Malaysia. A lot of people came to Malaysia. Many investors wanted to do electrolysis plant in Malaysia to produce hydrogen. So electrolysis plant can provide demand response of the category of providing a spinning reserve, primary spinning reserve. It's not just capacity or even frequency regulation. It can also provide spinning reserve capability. So electrolysis plant, okay, is something that we would like to consider if we ever embark on the demand response of a spinning reserve type. Next. So we also look at the various models that are available if ever TMB wants to do this. Mr. I can't remember, Nikishi or something from Japan, probably familiar with the model on the right hand bottom corner, internal on behalf. So we look at many ways to implement this. TMBX is a subsidiary of TMB. I was from TMBX. So we thought that if we do this demand response program pilot, TMBX will be providing the aggregator on behalf of TMB Retail. So if we look at the first model, external single aggregator, the aggregator sits in the middle, and then they have assets on the right hand side, flexible asset 1, 2, and 3. And then it will be providing services for TSO and all markets. In Malaysia, we unfortunately do not yet have markets, but we provide the services to TSO and DSO. And you can also have multi-aggregator model where there will be aggregator 1, 2, and 3. There will also be internal solution provider. The utility itself be the aggregator, and it appoints a solution provider. And there can also be the fourth model, which is internal on behalf, which is like in Tepco, with Tepco Retail appointing Energypool doing the operation on its behalf. But we think of doing the aggregator model with the utility appointing TMBX as the aggregator. Next. Okay, so we also look at contracts for demand response. So there are various ways of doing this. Okay, there's some literature survey that we did. What we look at was we already developed something called supply agreement with renewable energy for our customers. These are like solar PPA with individual customer, TMB as the billing agent. So when we install a subsidiary of TMB called G-Spark, we install solar panel on the customer's rooftop, and they sign a tripartite agreement called SARE. So we have developed the contract. We have signed up more than 100 megawatts, I think, now of customers. We thought of using that contract to provide this demand response supply agreement with demand response to customers as well. So, but this is still under study. So we may do that, or we may just take samples from Energypool and offer our customers. Note that TMB has offered interruptible tariff to customer before, and this is demand side management, but it didn't really work. And we also have demand. We also signed up few customers for interruptibility by our GSO. We had problems before when we had gas curtailments I think in the years 2011, 2012. So we signed up few customers for providing interruptible capability, but they are not compensated. Okay, or maybe it's compensated on a small scale. So so that was before. Now, if we are to embark on demand response going forward, we'll sign up a proper agreement with commensurate remuneration for the customers. Next. Next. Okay. So I think that that was the last slide. In conclusion, I think we did the study. Going forward, GSO has appointed TMB Research, where I am now, to test out a few demand response technology, mainly on the communication side. So we will try that one first. Okay, I personally hope that we will embark on demand response program in Malaysia, because we need to get the energy, our regulators agreement to charge or pay the customers, or to agree on the value provided by the customers. As you know that we need to pay the customers, we need to have an agreement from the regulator how much per spinning reserve, per frequency regulation to pay the customers. We need to get our regulator to agree. It's still under discussion. So once we get it agreed, then only we can offer this service to our customers. Okay, so that's our experience in Malaysia. Over to you, Madam Chairwoman. Thank you.
Thank you, Dr. Aznan. Many thanks for all your explanation about the DARE study in Malaysia. We'll now close this presentation session with a focus on the Japanese demand response market, especially on Energypool Japan activities, and on the cooperation with the Japan largest utility, Tepco. Our speaker will be Takeshi Ishimura-san, CEO at Energypool Japan. Please, Takeshi, you may start whenever you are ready.
Thank you, Moani. It's a nice back noise, and very happy to hear that. Lola, everybody, could you hear me?
Yes, this is fine.
Okay, great. So thanks for introducing me, Lola, and welcome to this webinar from all over the world. And my name is Takeshi Chimura, and I'm now the CEO of Energypool Japan. And my career starts at Tepco about 35 years ago. And I was involved in Tepco for more than 28 years. But maybe you may know that a huge earthquake occurred in Japan, 2011, March 11. And I can say that our nuclear power plant named Fukushima Daiichi was devastatingly destroyed by the tsunami. And this event not only changed the whole energy policy of Japan, but also changed my life as well. Without this earthquake, I never considered that I changed my career from Tepco to the French company, 10,000 kilometers away from Tokyo. But this is a very nice turn of fate for me to make some kind of an alliance with French people, and not only French people, but also any other Asian guys. I'm very happy to be here. So Lola, could you please go to next page? Thanks. And this is some kind of the brief history after I left from Tepco and joined Energypool. And 1 year of preparation for establishing Energypool Japan, being incorporated from 2015. And right after the incorporation in Japan, I was negotiate with my former colleague and for my subordinate to make an alliance with Tepco. So when it came through in 2016, and in the same parallel time structure, I negotiated with METI to establish a demand response market here in Japan. And well, this kind of the market is still now undergoing to establish further market, not only the capacity mechanism market, but also the balancing mechanism market. But from 2017, the prototype of the demand response market named 1-. This is just a call for tender from all over the aggregator, not only Japan, but also from the Western world, can join this market. And we've already launched a program with Tepco from 2017. And besides Tepco, we already made a contract with Kansai EPCO, the second largest EPCO in Japan. By the way, EPCO is an abbreviation of the electric power company. And following by the Chubu EPCO, It's a third largest EPCO in Japan, mainly in Toyota. It's an automobile company area. And I haven't mentioned here, but I think this is a good news for Energypool world. But I've already made a contract with a fourth EPCO named Chugo EPCO in this April. So at this point of time, our major client is 4 EPCOs in Japan. And besides these kind of the alliance, Tepco and Energypool both are very eager to make a strong alliance, such as investing in Energypool Japan. So at this point of time, Tepco Energy Partner is a retail arm of Tepco Holding, is now a minority shareholder of Energypool Japan, which means our relationship becomes deeper and deeper. Under these circumstances, we've already made some record here in Japan as a top DL player, and we've already established more than 500 megawatt, not only the metropolitan area, but also the Kansai area as well as the Chuba area. And we've already installed our DL box, the detail being explained by the Baptiste. But this one, it means more than 100 DL box being installed to the large-scale users here in Japan. And not only the one dash market, so-called the capacity mechanism market, we've already launched some kind of the balancing group demand response named implicit DL activation, which has been launched since 2018. And we've already launched demand stimulation to optimize the photovoltaic here in Japan since 2019. And in this winter, from January 5th to the middle of the January, so criticality was in critical here in Japan due to the lack of the liquefied natural gas, as well as you may know, that full suspension of the nukes due to the Fukushima Daiichi catastrophe. Well, even though the 10 years have passed, but anti-movement or strong allergy to the nukes is still existing. So these kind of some kind of the accomplishment with the Tepco. I'm now the member of the advisory council to the government of the METI, and this is very good advantage for us, because once we can make some kind of the proof of concept with Tepco as well as large-scale users, which belongs to Tepco, we can make a concrete proposal to the government, which can be more applicable as well as more sophisticated from the viewpoint of the TSO. Please, next page. So this is some kind of the status in an hour. And harsh competition were observed here in the retail issue. And 9 EPCO, well, in a complete, in an accurate meaning, I think we have 10 EPCOs, but Okinawa EPCO is a little bit far from mainland of Japan, so I often mention 9 EPCOs, but newcomers is more than 700. So this is a quite harsh competition observed in the Japan market. But currently, Tepco Energy Partner is now a quarter share marketer in Japan, and you can see the figure following the Chuba EPCO, Kansai EPCO, as well as a brand new client named as Chugo EPCO. So which means Energypool Japan have already made a contract with half part of Japanese EPCOs at this point of time. So please, next page. So some people may concern that why make an alliance with Tepco? Why not make a business as a third-party aggregator or independent aggregator? This is a very nice, good question, but I can have I can offer you a clear answer, because existing and the conventional lac is some kind of huge resources for making demand response. What a conventional lac means? LAC is an abbreviation of load adjustment contract, which have launched since 1959. And the two LAC exists, it's a planned LAC as well as occasional LAC. And the total capacity as a contractor base is more than 8 gigawatt. So when this kind of the contract made a strong alliance between EPCO and the large-scale users, so it's rather difficult to dive into or to make some kind of bud into these kind of relationships. So it's easier for us to access to EPCOs, and it automatically cascaded to the large-scale users for revitalizing conventional LAC to the modernized, digitized demand response program. And but before the March 11, 2011, this kind of the concept still remained, but everything is totally upside down due to this earthquake, and Tepco was obliged to implement a rolling blackout, and I was general manager at the time of the headquarters of Tepco. So this is some kind of the nightmare for me. So after that, Tepco decided to launch demand response program from conventional LAC, supporting with state-of-art aggregator. That is Energypool. And in parallel, METI take an initiative to install or modernize the demand response market here in Japan, and we can now make a business here in Japan. So after that, I'm very happy to show you some example. So Lola, please. So this is some kind of the structure from Greek company or retail company to the large scale users. So everything is totally digitized by through of the OpenADL as well as the 3Z and the LAN. And some large scale users are still negative to connect this DL box with a plant scatter. Oh, well, I can totally understand where they're coming from, because they do not want to make their operation line being controlled by their aggregator. It's quite a sensitive issue. So sometimes this number 3 point is not digitized, but analog style. But we've already launched this kind of the structure with more than 100 large-scale users here in Japan. So next, please. So this is some kind of, I can say, notable curtailment in this winter at the metropolitan area of Japan. So from 5th of January to the 8th of January, you can see that total curtailment from 421 to the 480. This is some kind of magnificent record from the viewpoint of government. And this graph have already quoted by the Japan Fundamental Energy Policy paper issued by the METI, and will be converted into the Japan Basic Energy Policy, which will be launched in June this year. So please, next page. This is the second concrete example that we launched with Tepco. It's a virtual power plant POC, proof of concept. So you may know that in Japan, thanks to the feed-in tariff as well as the feed-in premium, it's now the third largest PV installation nation in the world, followed by China and the United States. Then the per square meter, it's totally number 1 in the world. So which means that sometimes, especially in the spring or autumn, photovoltaic generated more than the existing demand. So some suspension of the photovoltaic can be observed, especially in southern part of Japan. So we try to avoid this suspension. So for that purpose, demand stimulation is one of the trigger to optimize or maximize the utilization of photovoltaic. So we've already launched this kind of program since this April, and which means making large-scale users more green enterprise, and which must be attributed to their ESG investment, I believe. Please, next page. This one is a proof of concept under the scheme of the primary reserve, R1, and since last year. And we've already prepared for launching this primary reserve market from 2024. And this kind of the proof of concept can be the prototype for the market design here in Japan. So thanks to the large scale industry, and we already launched our DL box as well as a transducer for monitoring the frequency as well as delta P. So that's all from my part, and I'm very happy to answer your question. So thank you for your patience.
Well, many thanks for your presentation, Takeshi-san. We'll now move to the question and answer session. Please use the conversation window to send your question to speakers, and we will answer them. We have a first question, which seems quite specific about water treatment. What do you think about demand response opportunity for municipal water transfer stations? How can we manage the customer satisfaction? What are the important points?
Yes. Laura, may I answer?
Sure.
Okay, thanks for Mr. Yalcin. I'm sorry, how do I pronounce, but it's a nice question. Yes, regarding the more than 100 our large our DL box installed users, municipal water station are being included. But as you may know that single municipal water plant is not sufficient enough to adjust some kind of the threshold for the demand response market here in Japan. So we try to combine with other resources in that area. But I think this concept is quite useful from now, because to some extent, large-scale user now is some kind of red ocean, but this kind of the municipal water station is still a blue ocean for the possibility of the demand response market. So I'm very happy to dive into this area.
Thank you. Next question about the use of electrolysis. Maybe Baptiste, you would be able to answer this question?
Yes, sure. So yes, electrolysis can provide the spinning reserve. Basically, thank you for your question. Sorry. So basically, this is a quite flexible process, and we often see this kind of technology in the spinning reserve. So basically, the electrolysis can adapt the power consumption quite easily. Of course, you need some automation and software, which we are a great expertise on that. And in the case of spinning that means concretely that there is a transducer on site to measure the frequency, and according to the frequency, we convert that signal to give an instruction of dispatch to the electrolysis system to modulate the power up or down according to the frequency. So there's a relation in between the frequency that is measured and the power that you have to deliver. So we convert that and we give the dispatch instruction to the electrolysis. So in general, electrolysis are one of the good potential for demand response because it can address many kind of services, so spinning reserve, but also the. Thank you.
Just checked. I was mute. Maybe a question for our guest speaker, Dr. Aznan, about the undersea cable at Langkawi Island.
Yes, thank you for your question. Use case for TMB Langkawi Island, yes, definitely. There are 3 cables, and we see a lot of demand going up in Langkawi Island, certainly before COVID-19. So again, we have to restudy that demand profile. I'm told that a lot of hotels have been closed now, so maybe it's no longer suitable. It's just a showcase because our previous Prime Minister was from Langkawi Island, so we chose it specifically to do smart grid related projects in Langkawi Island. So yes, previously it was undersea cable capacity limitation, and there was a vibrant tourist industry over there. Thank you.
Maybe a last question. Okay. Baptiste, would you answer this last question? Or?
Yes, thank you for the question. So I understand from the question that there will be a strong effort in the Asian countries to save 40. I mean, the peak demand should 40% of the peak demand should come from cooling. So there's a significant effort in the energy conservation, if I understand the question. So how should DR still have, how DR is still a key in that system? So in fact, energy conservation will reduce the peak demand, but still you have a huge new capacities to install. And in that, demand response play a key role, especially to mitigate the renewable integration, because energy conservation does not deal with the intermittent energy generation from renewables, for instance. So this kind of flexible tools are still key in the system to mitigate the intermittency, but also to reduce the capacity install in the long run. I hope that answered the question.
Okay, well, if there is no other question, I think we can stop the webinar here. Thank you very much for your participation, and we will send the presentation and the video of the webinar in the coming days. Thank you all.
Thank you.
Thank you, Laura.
Thank you, everyone.
Thank you, Laura. Thank you. Thank you all.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.